I am horrible about pressing start record. And so if you are brave at all, just wave at me and say, did you remember to start recording? It will make everyone who had to miss a class because they were at a different activity life so much better. Just tell me to start the recording. I would be grateful for the reminder because I have forgotten, and then it's a pain because I have to try and recreate a lesson. So in your ACT packet, there's either a spiral bound or a stapled packet of math, and this is the overview or the basics of all of the different math subjects you need. And so we tend to follow along with this to give us some structure and some basics, and then you have it available to you if you need to. Oh, we have so many people online again. Admit. All right, we were just getting started. My name's Aubrey, I teach math, and we were getting out the little packet that has the math in it to help you follow along. So if you open up to the very first page, we won't go in order for the entire class, but we're starting with geometry today. And so either online or here, if you have already finished geometry, raise your hand. Okay, so some of you have already finished it in the class, and one online already as well. All right, if you are currently taking geometry, can you raise your hand? Okay, current and online. Any current geometry students? One there, 2, 3, 4, okay. So a lot of you are currently in geometry. If you haven't already taken geometry, a lot of what the, at least Iowa curriculum considers to be state standards or levels, and I'm assuming that South Dakota or Nebraska would be close as well. A lot of what you learn in those classes is also the geometry that you need. A lot of the geometry on the ACT is going to be those basics. And so if you're rock solid in those basics, you can do pretty well. So if there comes something that you're like, I really don't get that, we do have to go through a lot of material and have the entire class going. But if you message in that regular ACT chat, I can answer any individual questions you have. And so if there's something that you're like, I didn't get that, please get back to me. Along the same lines, there's a homework schedule for this class, and the math is kind of staggered differently than necessarily when I'm teaching. But if you want to send a question to that chat or bring it to class from the homework of, hey, what was this asking about, or why were we supposed to be doing this? And it can be any math, not necessarily what the topic we're doing for that day. If you want to send a question, I would be delighted to answer. So that's the foundation. All right, so the following questions that we do in this class are not going to be this wordy, because otherwise you're waiting for me to write a lot of stuff. And so from now on, I'll just put the gist of a question up here. But this kind of gives you the impression of what does an ACT question look like. And so this first one says, the line containing points A, B, C, and D, B is between A and C, D is between B and C, and which of these inequalities must be true? So if you haven't taken geometry, just so you know, BC is talking about the length or the distance from point B to point C. And so that's a notation thing. But always, 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 they didn't give you a picture. Give yourself a picture. We have B is between A and C. D is between B and C. So take advantage of the lineness. You don't have to get things on the very end. Give yourself some wiggle room. B is between A and C. Okay, here's A. Here's C. Here's B. But, oh, we've got more online again. But we also know that D is also between B and C. And so we have to fill in this blank that D is also in there. And so now we have something to work with. Here we have BC compared with AB. Well, here's AB and here's BC. In my drawing, the BC looks bigger. But the other thing you have to be aware of with geometry, even if they had given you a picture.
Oh, sure. Good.
I'm sorry? Okay. Even if they have given you a picture, you can't trust the picture. It's not always drawn to scale. It's not always right. And so rather than thinking of these as fixed points, think of them as like beads on a string. They can slide anywhere along that line. They just can't cross each other. Because we were told this is between, D could slide really, really close to C, but it can't flop places. It can't switch. So, AB could be bigger. As drawn, we see that BC is bigger. So this one is not must. Could be, doesn't have to be. BC, oh, I copied the same thing twice. I wonder what it was supposed to be. Oh well. You know that one's not right, so hopefully I didn't omit the correct one. BD is going to be smaller than CD. So again, D could move anywhere along here. Could be anything. And so this one does not have to be. Maybe BD is smaller, but maybe it's larger. It could slide anywhere. Finally, CD has to be smaller than BC. BC is here. CD is here. And so again, it doesn't matter where this slides, it will always be smaller because BC is part of that unit. It's contained within it. And so this one is the must be true. Level of difficulty, this would be a middle of test question. They're not going to give it to you within the first 10 questions, but it's also not going to be in the last 5 to 10 that get really challenging. This is around the middle of the road. So, I'm curious if that's person asking to be admitted. I don't know. Move it away. So, could you solve that second one on your own? What do you know? What can you figure out? If you're taking the test on paper, they encourage the scratch paper. You can draw all over the book. You don't have to worry about having separate scratch paper. If you end up having it testing online, scratch paper will be provided for you. But this is a question that I really, really encourage. Have something to scribble on. They do give you the picture. Again, you can trust that that's in the right order. You can trust that the points are in the right spots, but you can't trust lengths. You can't just plop down a ruler and check it. So the way that I handle this is to recognize that the entire thing is 30. I like to draw a bracket or a brace representing this whole thing is 30. We know that AC is 16. And we could say that BD is 20, but it starts getting a little bit messy. And so it's easier to use both sides of the drawing. The other thing that helps with this a lot is to ignore part of the problem. A huge part of geometry is knowing what you need to pay attention to and what you can ignore. If you ignore this piece right here, if the whole thing is 30 and this piece is 16, how long is this piece right here?
14.
Yeah, it's just going to be 30, the whole thing. Take away the part we know, 16. 14 is left over for this piece. And now we can do the same process again. Ignore the stuff we don't need. Use the stuff we have to find out what we want, which is this piece in the middle. And so if we ignore this, we have that this whole thing is 20. This part is 14. How much is left over for that middle piece? It would be, the 20 minus the 14 equals 6. And so RBC equals 6. And so segment addition is one of the first things that you learn in geometry. If you're currently taking it, you are probably doing it now or recently did it in class. But that ability to say, okay, just focus here, 30, 16, 14, and then just focus here, 20, 14, 6. That makes the segment addition much easier. When it's just one chunk of long and then two pieces, it's very simple. You can do it in your head. When it gets more complicated with multiple measurements, it helps to break it down into smaller problems. And so this one could easily be in the first 20 problems of the test. It's considered a staple basic. All right, questions about segments. That's our first section in your notebook there.
If you have no like inches or anything like units, do you have to write like units, or do you just write 6?
Because it is multiple choice, that question's really easy. You just go with what they present. Frequently, they just present the number. But the multiple choice would catch that for you, which is good to have. That being said, being careful about units or units squared, that one could be something that they are actually testing on and would be given as your options. So that is a good thing to be aware of. Good question. All right. So the next section in your book that you need to be aware of is angles. And angles is interested in the difference of direction. An angle is about how different are the directions of two pieces, whether they're segments or lines or rays. Angles about the difference in direction. So, one of the fundamental things that you should be aware of What is the measurement of that angle? 90. 90 degrees, right angle, perpendicular, all of those things are very, very familiar. And in particular, being able to recognize that little square mark means that it's 90 degrees. They use it all over the place. Also, in that same category, what is this angle measure? 180 all over the place. And in particular, when we have two angles making that straight line, it's called a linear pair, or literally a line pair. And the fact that the two angles together add up to 180. Just like we just did that segment addition, that the two pieces added up to the whole piece, or the whole thing minus the piece we know equals the piece we don't know, that is also going to happen with the angles. So if we call this and this y, the whole thing is x plus y. Also, for naming angles, they're going to use the points, and so A, B, and C. This could be angle ABC or angle CBA. Order isn't particular. The important part is that this corner is always in the middle. And so you are literally tracing the angle with the three letters. This corner is called vertex. And there's a couple problems that use that vocabulary with it. Frequently they just give you the picture. But the fact that the two angles add up to the whole thing, exactly the same process of solving as the segment addition, it's just presented in a different way. And in particular, this linear pair shows up everywhere. So, one last thing with angles. Do you remember what those two little green angles are called? And even if you don't remember what they're called, do you remember what's special about them? They're the same.
Vertical angles?
They're called vertical angles, and they are the same measure. They're the same size. If one gets bigger, the other gets bigger. If one gets smaller, the other gets smaller. I call them bow tie angles, because that's what my brain sees when I look at them. But those are going to be congruent, or the exact same measure. And so that is something that we can use a lot. Finally, with angles, we have parallel lines cut by a transversal, or a line that crosses both of them. There are a whole bunch of names that you learn if you take geometry. They are called alternate exterior angles, alternate interior angles, corresponding angles, consecutive or interior angles. You don't have to know any of those words for the ACT. What you need to know is that this angle is the same as this angle. As long as you've got those parallel lines, the corresponding angles are congruent. And from that set of information, if this is 50 degrees, this is also 50 degrees. But we just talked about those vertical angles. And so if this is 50 degrees, this is also 50 degrees. And we talked about our linear pair. that these added up to 180 degrees. And so not only do we know this is 50, this is going to be 180 minus that 50, or 130. And not only is that 130, but our vertical angle is 130, our corresponding angle is 130, and our vertical angle, again, is 130. And so when we have these parallel lines cut by a transversal, there's only two possible angle measures. It's either the same as the one angle they give you, or it's what's called the supplement, or the other half of 180. And so again, there's a whole bunch of names that you learn in geometry and you work with, but for the purpose of solving, all you need to know is that it's one of those two. It's either the same or it's supplementary. And again, they make these bow ties. And so very quickly, if I tell you that these are parallel and were cut by a transversal, all of these angles will be the same. And the other ones will be the other half, or what makes 180 with your given angles. So again, in geometry, you've got a whole bunch of words for it. You only need those tools. All right. All right. I'm going to erase the right angle and this one. Yeah, the right things. So we are given a drawing that looks like this. We have a right angle here, we have a right angle here, and drop down, we have a right angle here. We have A, B, C, D, E, and F. And the question says, which of the following statements are not justifiable? Which of the following statements, is not justifiable from the given information? So they've given us this picture. They've given us the right angles, and they've given us multiple choice 5 statements. And only one is going to be not necessarily true, or not true all the time. This is a problem 50, so it's fairly high up in the test difficulty, but it's still doable. And the first thing it says is that AB is parallel to EF. So using color, does this have to be the same as this, the same direction? And the answer is yes. The reason why is if we imagine this as that transversal, we have a right angle here and a right angle here. They are right angle here as well, because if one's 90, the other's 90 in order to make that straight line. And so these are corresponding angles, they're the same. That makes it parallel. It makes it going in the same direction. And so that first thing, yes, it has to be true. Those two have to be parallel. Next, they say that DE is perpendicular to BE. So DE and BE are those two lines right there. Do they have to be perpendicular? So remember that perpendicular? Marker's getting out. Means that they meet at right angles. Means that they are 90 degrees. And in the given drawing, they gave it to us right on the picture that DE and BE are meeting right here at right angles. And so yes, definitely perpendicular. I would feel really confident about that one and cross it out. I know for a fact that's not the one that doesn't have to be true. ACB is congruent to FCE. And so that one, there's a lot of letters going on. ACB is, we're talking about this angle right here. And FCE is this angle right there. Are those angles going to be congruent? Yeah, because they're those vertical ones. Another one to cross out. We know for sure this is not ever going to be false. It has to be true. And we're looking for the one that doesn't have to be, not justifiable. BAC is similar to EFC. BAC, I wish I had another color, but what am I do? So BAC is this angle right here, is congruent to, is similar to EFC. So that's jumping ahead a little bit. To be similar, it means that it's the same shape. It could be a different size, but we know that it's the same exact shape. And if you picture, have you ever done a PowerPoint in school and you try to put a picture into the PowerPoint and you go to move the picture and all of a sudden you've drug the corner funny and the picture looks wrong and you know that it's wrong? That's your body interpreting not similar. If we resize a picture and the proportions stay the same, then it looks right. It's just a different size. But if you mess up those proportions, it gets distorted. The nose is too long, the body is too wide, something goes wrong. And so in order to be similar, it's going to have the same shape and it's going to be proportional. And with triangles, it happens to be really easy to get them similar. All it takes is two pairs of congruent angles. To show that triangles are similar, two pairs of angles are enough. And so one, we already got this one from our vertical pair. And they gave us a right angle here, and we have a right angle here. And so yes, these are going to be similar because they have that two pairs of congruent angles. So that one's a little bit trickier if you haven't learned about similarity in geometry yet. To be aware, that's what makes it similar. But back to the technique of test taking, we already eliminated two that we knew were wrong, that they could always be true. And so even if you don't know everything, if you can cut down your options, it makes it a much better guess. And so even if you have no clue what similar is, you can still work with the stuff you know in order to make a better answer. And then finally, CE is congruent to ED. And so does this side have to be the exact same as that side? And as drawn, it looks like it, but honestly, no. Again, I would draw on the picture. I can move this over here, and it would make B look like that, but there's absolutely no reason that this can't still be a right angle. This can't still be a right angle. These are still vertical angles that are the same. Everything else holds true if you move E so that these are obviously not the same length. And so it's very, very hard to do if you're looking at the picture they gave you, but acknowledging, well, I can keep everything else true and draw it very differently. And that is what makes that one false. These look like the same in the picture they gave us, but it doesn't have to be. So again, that one is at the upper level of difficulty of what you'll see in geometry, but I picked that question because it lets us talk about the parallel and the vertical and so many of those other things. All right. I'm trying to remember what it does next since I'm trying to go in order of what they gave. A parallel. All right. So, for the second half of the lesson, I'm going to focus in on perimeter and area. And that is something that I'm sure you have done before, but I want you to be really comfortable with it because it shows up a lot. So, there are no formulas given to you, and there's no notes. So, we're going to talk about how to build the formulas for perimeter and area. First question, do you remember how to find the area of a rectangle? Yeah, what is it?
Base times height.
Base times height, length times width. I like base times height. And for perimeter, it's just the distance around. You are going to add up the four sides, and you have two bases and two heights. So you have either base times height equals our area, or two bases plus two heights equals the perimeter. Next, I'm going to draw three separate cases. What is the formula for the area of a triangle? Rectangle's really easy. Do you remember a triangle? Yeah.
Base times
height divided by 2.
Base times height divided by 2, or 1/2 base times height. It's a complete personal preference of which one you remember it as. But let's talk about why. Because if you remember why, it's much easier to remember the formula. This triangle is literally half of that rectangle. And so the right triangle, it's really easy to see that this is base times height divided by 2, or 1/2 base times height. This one, if we draw in the rectangle, this is our altitude or our height, at the right angle. And again, we literally have half of this rectangle and half of this rectangle, so we have half of the total rectangle. And again, it's base times height divided by 2. If we extend it out here, when you're given a triangle that's hanging over the edge like this, this is still the height, the distance from the ground or from the base at a right angle. But the base is still just the length of this side. This formula still works. One of the easiest ways to think about it is to think about cutting this into teeny tiny slices and then just shoving the stack straight. It still works. Mathematically, you can prove it by finding the area of this big triangle and subtracting out the littler triangle if you want to, but just know that the base times height still works. The height is the vertical distance. The base is only the length of the side. So those are the 3 situations you'll see with a triangle. All right. Classic problem you will see on the ACT. I give you a 50% chance of seeing a trapezoid. And this is the one that, honestly, everybody struggles to remember the formula on. You would be given these 2 lengths as base 1 and base 2, and you would be given this height. How can we find the area of this trapezoid? Again, I like to know where the formula is coming from, so I'm going to show you the logical way first, and then I'm going to show you the way of, I hate trapezoids, I don't want to deal with them. So, the logical formulaic way is to acknowledge that there's a middle in here. This middle is the average of the 2 bases, which is literally just add base 1 plus base 2 and then divide by 2. Find the average. It's the exact middle. And what that means is we can cut off this little triangle here and put it up here. We can cut off this little triangle right here and put it right here. And we have literally turned it into a rectangle. The formula for the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. And that's where it comes from. If you hate trapezoids, if you say, no, that still doesn't make sense to me, the other way to deal with them, and on the ACT, it's a free-for-all. Get the answer any way you can. If this is 7 and this is 15 and our height is 10. You can use this formula, but you can also use the idea that area is the sum of the pieces. And so here, the area of this rectangle in the middle is going to be 7 times 10. We have 70 units squared. And then we can take, where did I lose my green one? There it is. We can take this piece and this piece and shove them together. we have no idea how much is on each of these two pieces. But we know that together it has to be 15 minus 7. And so there's 8 left over for that base. Again, I don't know how much. It's not going to be equally 4 and 4. It could be 3 and 5. It could be 2 and 6. We don't know. Probably decimally, honestly. But we know that together it is 8, and this height is still the 10. So 8 times 10 is 80, divided in half. This equals 40 units squared. So 70 units squared and 40 units squared, we have 110 units squared. And so if you truly just don't remember trapezoids, treat it like a rectangle and a triangle. You can find that area. Questions so far? I got going with the trapezoid. I forgot the easier one. How about a parallelogram? What's that area gonna be?
Base times height.
Base times height. And again, it's because it's exactly like the rectangle. We can take this corner and chop it off and put it over here, and it's a rectangle. Base times height. So area definitely going to be on your ACT test. At least on 3 to 4 problems, probably more like 7. Yes.
The area is just the same for that one too. It's base times base times base times, or base times base plus height times height, or something like that.
Oh,
Is
the
it
perimeter?
Yeah, perimeter. Isn't it the same as a square?
No, unfortunately. Because notice how this height is shorter than this right here. We're going to have another geometry lesson later on where we deal with the Pythagorean theorem. And so if they didn't tell you outright, we'd have to go back to the Pythagorean theorem, a squared plus b squared equals c squared, to figure out that slant.
Okay. So there's no direct way to.
Not unless they just tell you outright.
Okay.
Sometimes they'll just label it. They'll also, when we get to the Pythagorean theorem lesson, remind me, if I don't, I'm sure I will, but to talk about Pythagorean triples. Those are the numbers that work out nicely into a nice pretty number, and they love them. They use them a lot. Taking a break while I erase the board. Little bit of history for me. I took the ACT when I was in 8th grade because my tag teacher told me to. I had no clue what it was about. So if you are here before then, congratulations, you are ahead of me. But I did decently. A lot of people would be happy with it. I got a 25. And there were questions that I knew, and I knew really well. And there were questions that I had no clue about. And that's okay. So you can score a decent score even with just the basics. But I took it again when I was a junior, and I did really well on reading. I did really well on math. My English score was not great, and my science score, you just get tired by the end of the test. There is an element of marathon to finishing the test. Your brain starts getting tired. And so I thought, okay, that's what it is. But I had a really, really good English teacher. And a lot of that English stuff that I was just kind of getting by with, it clicked. And so it's like, oh, I I should take that test again. I bet I can do better. And I went and I tested, and my reading score was really good. And my math score went down, and my English score went up, and my science score was still just hanging on there at the end, and I got the exact same score. And the reason why was I forgot my calculator for the second test. I took it straight pencil and paper. It is doable. Every question on the ACT could be answered without a calculator. But it's already hard enough to get it done in an hour. Getting it done in an hour without a calculator is a really, really hard challenge. So, Manoj will hit it really hard. You should take 2, because I have also seen calculators die while I'm proctoring the test. But do not forget your calculator. So that's the story with that. The last one that we have for area is what is the perimeter of a circle? Again, these are the ones that they expect you to have memorized because there are no formulas. Whether you choose to use 2 pi r or diameter times pi, it's a personal preference thing. Remember that the diameter is all the way across versus the r is the radius, and that's just from the center to the outside. As long as you remember the relationship between the two of them, this 2 and r gets replaced by diameter. 2 radiuses make a diameter. This one, you just have to memorize outright. It's because pi means circumference divided by diameter. That's where pi is generated from. And so there's nothing you could do. That's just the definition of what pi means. But what you can do, and how this formula comes about, is that if we cut the circle area into a bunch of teeny tiny pizza slices, we could arrange this with half of the pizza slices across the bottom as a set of triangles. Wrong way. And then the other half of the pizza slices fitting across the top. And so half of 2 pi r is just pi times radius. And the height of this parallelogram is literally also just a radius. The distance from the outside to the center, or the center to the outside. And so the formula for the area of a circle is pi radius squared. I honestly don't re-derive this one. It's just kind of interesting and helps me remember. But just memorize 2 pi r, or diameter times pi, and pi r squared. Those formulas will get stuck in your head, and you'll remember that pi goes with circles, and then your brain starts saying, which one? And you'll get really hesitant about, okay, I know that there's these 2 of them, but which one do I need? The hint is in the formula. What is area measured in? We had the question at the beginning about units. What kind of units is area measured in? It doesn't help the online students, but for you here, look down at the floor. What shape is covering the floor?
Square.
Squares. And so area needs to be measured in squares. If you measure, I don't know, 2 feet over and over and over again, you're just measuring 2 feet over and over and over again, and it's never going to cover a surface. In order to cover a surface, we need to have 2 dimensions, or squares. And so this formula is pi r squared. The one that says squared is the one that's going to give you squares. It's going to give you area. And so that's how you keep the 2 separate. 2 pi r, or diameter times pi, that's the distance around the perimeter of the circle called the circumference. Pi r squared, if it's got the squared in it, that's the one giving you area. All right. Kites. Forgot kites. So, last area is a kite. A kite is a special quadrilateral that has congruent sides, but rather than being opposite each other, like a parallelogram, they're right next to each other. And this one again, the primary useful bit of knowledge about a kite is that its diagonals are perpendicular. They meet at those right angles again. We've got the perpendicular, we've got those right angles. So again, it's just going to be half of the rectangle. And so it's diagonal 1 times diagonal 2, and then cut in half. All right. Couple more problems before we go to break. First one. That's 148. I apologize for my handwriting. I'll make this one clearer. And we want to know, what is this? I apologize. I realized I meant to talk about this one back when we were in parallel lines, but I got distracted. So, the one other really useful piece of information is that just like the linear pair adds up to 180, the straight line, the angles of a triangle also equal 180 degrees. And so you can use if this is 148, you can find this angle. If this is 140, you can find this angle, and you can use it to find that third angle. There's also one, if you were in geometry, called the exterior angle sum, that's a tiny bit faster, but for the purposes of being confident and right, we're going to keep the topics small if you don't remember the shortcut. All right. This one's 140. What is this angle?
40 degrees.
40. Good. And you can use the mental math shortcut. You can type it in the calculator as well. But if this one's 40, this one's 148, this is 8 more, that means that this has to be 8 less. And so this one is going to be 32. And finally, we can take our 180 for our triangle and take away 40. We get 140. Take away 32. And what's left over? I will always say calculators are fine, but
108.
108. And so this is our angle. What would this one be? This is a real ACT problem. I've seen it on a few different tests throughout the years. It's got a whole lot going on. You've got a right triangle, you've got 66 degrees, you have this angle called Z, should put a degree by it. You have X and you have Y. And they tell you if X equals 40, I am always big on writing that in. They want to know why. And knowing what you're looking for is very important. We are looking for y. But we've got a straight line. All of this other stuff, it's just noise. It's just chaos. If this is 40, what's y?
40.
Almost. 140.
Oh.
And now I'm writing the wrong thing too. 140. And so don't let the chaos get to you. Focus in on this is what I have and this is what I need. And you will go far. All right. We're going to take about a 5-minute break. If you need the restroom, it's down the hall on the left. And we will go from there.